Angles of triangles. Right, so just a slight review here. We know that each triangle is made up of 180 degrees. So if I took the measure of angle X, the measure of angle Y, the measure of angle Z, if I were to add these three together, they're going to equal 180 degrees. Let's put that into practice. When we see this, now we have complete abstraction here, right? There's no figure. We're not going to look at triangles. What we do is we understand the rule, and we can create it with our spatial analysis here and our understanding of how things work. We can create the scenario in our brain while we're doing the work. What this tells us is if triangle XYZ, so that is a triangle with an X angle, a Y angle, and a Z angle. We do not know what it looks like. We don't need to. Has a measure of angle X, which is 72 degrees. That's the measure of angle X. And the measure of angle Y is 74 degrees. And what we don't know is we don't know the measure of angle Z. So angle Z is unknown. What we do know is by rule, each triangle has 180 degrees. So I'm just going to set that equal to 180 degrees. And if I add the three of these together, I should be able to figure out what Z is. So first thing is let's combine like terms here. I have 146 plus X equals 180. I subtract 146 from both sides, and I get X equals 34 degrees. And by doing that, very simply, I know therefore, well, let me use my therefore dots. Therefore, not really a good therefore situation, but I'm using the measure of angle Z is 34 degrees. Completely abstract. We're given two angles. We should be able to figure out the third one based on the rule for the angles of triangles. Now we're going to get even more abstract. Let's read this problem. The measures of the angles of triangle ABC. All right, so triangle ABC is a triangle with a vertex of A, an angle of B, an angle of C at the other vertex. And they're in the ratio of 1 to 4 to 5. What's that? Okay, so the ratio of 1 to 4 to 5. Okay, so what does that actually mean when we talk about a ratio? What we're talking about in a ratio is that if I have 1 of something, my next value in this case is 4 times as big as that. And then my third value then is 5 times as big as this one. So if we look at that, we can break that down using an unknown because we don't know something. We need an unknown. If we describe the 1 as just X, then our second value in the proportion would be 4X. Then our third value, 1 to 4 to 5, is 5X. Now we have our angles here. Those are our three angles. When we add those three angles together, what are they going to equal? You got it? Oh no, purple, sorry. Let's go with blue. You dropped the ball. They're going to equal 180 degrees. So if we add these three together, we're going to get 180 degrees. So let's check and see here. Oh, well, there's no degrees in there, Mr. Romanovich. All right, so let's combine like terms. I've got 1x, 4x, 5x. If you need to, put your training wheel back on. There's nothing wrong with it. 1x plus 4x is 5x. 5x plus 5x is 10x, which gives me 10x equals 180. Now we are dividing, and we get x equals 18. Are we done? No. We need to have the three angle measures. So our first angle measure, as we substitute this back in for x, our first angle measure, and let's just describe it as A. The measure of angle A, we'll say that's A, is 18 degrees, 1x. The measure of angle B, that one's going into this spot, B, is 4 times 18. 4 times 10 is 40. 4 times 8 is 32. 40 plus 32 is 72 degrees. And then the measure of angle C, we'll call this one C, is 5 times 18. 5 times 10 is 50. 5 times 8 is 40. 40 plus 50 is 90 degrees. How do we know if we're right? We could add them together. 8 plus 2 is 10. Carry the 1. 1 plus 1 is 2, plus 7 is 9, plus 9 is 180 degrees. We have it right. So finding the angles from just the ratio, that's how we would do that. We ascribe the x value with each of these, the coefficient being if it's more than 1, and then we're setting it equal to 180 so that we can solve for x and then figure out what the three angles are. Okay, now there's one more concept that's a step beyond what we've been doing here. Please notice the diagram. Okay, we look up here at this triangle. This triangle has an extra piece to it right here. And what it's formed an additional angle. So we have this angle right here, angle 1. Now, angle 1 is not inside of the triangle. Angle 1 is outside of the triangle. And that's why we would describe angle 1 as an exterior angle. Excuse me. So an exterior angle is an angle that gets formed by one side and the extension of an adjacent side. So if we go back and look at what we've got here, we've got an angle that's formed by this side, AC, and then BC extended. So when those two meet and then we extend BC, we create that exterior angle of angle 1. Now because that's an exterior angle, we also have a situation where these two angles over here now get a name. Okay? And that name is remote interior angles. These are the two angles that are capital N, capital O, capital T, not adjacent. Let's remind ourselves adjacent. Adjacent means next to the exterior angle. A-N-G-L-E. They are not adjacent to the exterior angle. This angle is two remote interiors. They're angle A and angle B. Now let me tell you a secret. The secret to this is that the measure of angle 1, our exterior angle, is congruent to the measure of angle A plus the measure of angle B. So in regular words, an exterior angle is equal to remote interior angle 1 plus remote interior angle 2. So if I add these two together, it will equal that exterior angle. Let's give it a try. Here's our diagram. We've got our triangle here. We've got two lines that are extended. We've got two exterior angles. We've got three interior angles. Lots going on. This is great. We get to figure something out. One of the things that's great about geometry is very puzzle-like. We get to pull things apart and prove things based on the things that we know are true. Suppose that the measure of angle 4 is 135 degrees. Find the measure of angle 2. Let's find what we're talking about here. So the measure of angle 4 here is 135 degrees, and this is angle 2 we do not know. Go back to our understanding of how this is. I've got an exterior angle, and that exterior angle is equal to the two remote interior angles. Those remote interior angles are the ones that are not adjacent to this, so they're opposite this. So I don't know this one for sure, so that's a mystery. So I have the measure of angle 2 plus the measure of angle K equals 135 degrees. We're going to need a little more data. We're unsure about this one, so we're going to make that x. That's what we've got to solve for. X plus, now, what's the measure of angle K? There's no number there, but there's a symbol. And that symbol tells us the measure of that angle. So that is our right angle symbol. So we know that this is 90 degrees. And that's equal to our exterior angle 135. It's all falling into place now. So now we're solving for x, and we subtract 90, and we get x equals 45 degrees. That technically is not what we're looking for, though. What we are looking for is the measure of angle 2. Now the measure of angle 2 was x for us, so we're going to say the measure of angle 2 equals 45 degrees. Simple, logical steps, yes. Be organized, yes. See what you're doing. It's very easy. Don't get lost because you don't do the work. Good luck.